Okay. So I'm just creating a new project, new Java project. And then, so if you want to create a Java project, you have to give the name of the Java project. So simple Java operations. Okay. So as we have done before, we can create a new class. So generally, I'm creating a class which can do calculation. So it means a calculator class. So I'm creating a calculator class. So what is the basic, states and behaviors for a calculator? Anyone? What can be the state and what can be the behavior for the calculator? So anyone, like, what is the state for the behavior? What is the state for the calculator and what is the behavior for the calculator? Yeah, I cannot hear anyone.
Public.
Yeah, Shalija, yeah, go ahead.
Um,
Okay, so basic state for the calculator would be like, state would be two numbers, right? Whatever the two numbers that we take, we have to either add or whatever it is. The state is, so int is the data type. Int is the data type, and we can have number one. So that number one is the current state. It can, any calculator can have at any point two numbers. So int number one, int number two. So this is the current state, and then the behavior of the calculator would be like public. So the public void, so it can either add, so which is a function, so it can do the add. So public void subtract. So public void multiply. And then you can also add division, whatever, right? Whatever different characteristics that you have for the, for the calculator, you can add all the operations as the behaviors. So behavior is any action that is happening. The state is anything that is the current state. Current state is whether you are adding two numbers, which is 21, 22. In some other calculator you might be adding 34 and 35. In some other calculator you might be you doing multiplication of 22 into 32. But the basic design is it can accept two numbers, and that two numbers, so basic simple calculator I'm saying, it can accept two numbers and it can perform addition, or it can perform subtraction, or it can perform multiply. This is the design of a calculator. So from this, can we create an instance of it? Yes, we can create 100 instances of it. This is a design. So we can create 100 instances of this kind of calculators to do so the basic operations of the calculator. So if you see here, these two are called the states. These are all called the behaviors of the behaviors. But because in the class we don't call them, the class is just a blueprint. When we create an object, then we'll define all of them. So when I create an object, so object can be created only when you create that using that new tag. So I'm just creating a main class where I can start the program. So in Java, if you want to start and run the program, we need to have a main method. So this is the main method. So until or unless you have this and everything is called under this, you cannot even start the program. So now that you have a calculator class, we can create an instance of a calculator class. Calculator class C1 is equal to new calculator. So from the design, we are making one calculator with this line. So that's what this line describes. So calculator class C1 is equal to new calculator class. So now we made a new copy of the calculator class. There is something calculator CLA. So there is no L cap, not capital. So Java is case sensitive. Be aware. So if there is any L capital or small, so they are two different things. Okay. Equal to new calculator. So we have to use new keyword. So now when we created this line, right, it has created one instance of the calculator class, which is nothing but one copy of it, and then that is stored in here now. Now I can go and say C2 dot number one. What is the number one? So in the first calculator, I'm doing the calculation. Number one is equal to 21. So in this current calculator, I'm doing that. C2 dot number two is equal to some 32. Means we have defined the state as these two numbers should be added or multiplied or subtracted. Then we are telling the behavior. Okay. Now C2 dot, you can just say add. So means you are trying to, now you gave the state as two numbers, and then that two numbers you are trying to do a action that is not but nothing but the behavior. If you take any real world object, anything, pretty much anything, it will have two things. One is state, one is behavior. So if you take humans, or if you take chair, or if you take anything, the chair will have some physical properties like color and all those things. Color, legs, the position, the style, etc., etc. So what is the behavior? You can just move chair, or you can just lift chair. So those are all behaviors. So if you take if you take a fan or anything, any pretty much any object, you will have two things. One is state and behavior, and you have a design. The design is called the blueprint. So anything that comes, the object comes out, it has a blueprint. Like if you take any object, pretty much you'll have if you take a house, it will have a blueprint. If you take a fan, it will have a design. If you take a computer, it will have a design. So the designs are nothing but the classes, which are called blueprints. The objects are the ones that we make out of that classes, which are called which are instances of the classes, are nothing but the copy of the classes that has some states and behaviors. Because here we have defined that there will be like this, but we have not defined the numbers 21 and 22. Where are we defining that 21 and 22? We are defining here, because this is an object, that is a class that's still in the design phase. When we concretely build a calculator, then in that calculator only we can try to calculate it. Okay, so that's the main important concepts of the class and object. I'm again reiterating because it's very very important. All the states are stored in variables. I'll discuss more in variables in coming in this class itself. These are all called variables, and all the behaviors are stored in functions. You can call them functions, you can call them methods, etc., etc. You can call some call functions, some call methods, some call subroutines, etc., etc. Whatever they named, they are all they define the behavior. And the variables that you define, like the color, string color, or string height, string weight, or string whatever it is, those are all defines the state of it. So one defines the state and one defines the behavior. Okay, any questions till here? So a class, again I'm just reiterating, is a blueprint, is a design, and a variable and an object is a copy of that blueprint with some specific things called states and behaviors. Although you have defined in the design, they only get that only get a meaningful information only when it becomes an object. Because here it's only a design, the calculator itself is design. The number one, number two doesn't make any sense in the class. You have designed it that it can go accept two numbers or three numbers or four numbers. When it will become a meaningful sense, when you create a copy of it and you make that into real. So that reality will happen only when you create an object, and that object will can take state and then take the behavior. Any questions, Kavita?
No.
Yeah. So, any questions, Raja or Shailaja?
I mean that every object, every design has an object and a behavior. Yeah, no, every design has a state and behavior, right?
Every design we will define the states and behaviors, but we'll not have concrete evaluation there. See, when we
Okay.
design something, what we will say? We'll say that okay, say let's say we are designing a house, so we'll say that
Yeah.
we need a bedroom, we need hall, we need this thing, we need this color, we need to have a color. We'll define we need to have a color, but we'll not say
Mhm.
that okay, because the color that you're taking is individual's choice of that guy who is building that house. Correct? In the design,
Yes,
what
yes,
we will say, a house should have a color. That's it.
yes.
In a house should have tiles. What tiles that you have to have in the design is, so you don't define. You will only tell that okay, here you have tiles, here you have carpet, but what color you have to have, the guy who is developing that object will have that color, the color that is defined. So because that's where you will have the collection, right? So you will go and say
Mhm.
for my house it will have this style, but the design is same. Correct? The design is the same design you're building for 10 people, but each guy
Yes.
will say okay, I don't need this tile, I need other tile, because he only defined that there will be a tile, but what tile he has not defined it. He only defines when you go and prepare that into a concrete solution. That is means you're building a house. The design is still in paper, right? So the class
Yes,
is
yes.
still in paper. The only thing that when it becomes a life is like whenever you create an object.
Okay.
See, in Java, you will see it in programs. In real world, you have to imagine like that. That's how it looks like.
Mm-hmm.
See, you
Okay.
cannot say like, oh, here is the class, here is the object. Why they are differentiating? No, it's like your imagination should be like that. So the design
Mm-hmm.
is something that you have it, and then from the design you are pulling many objects. Why you are doing like that is because of reusability. So see, now the same design you are using for 10 different things as 10 individual objects. So the same thing you are reusing it, right? Same different thing you
Yes.
are just reusing it and redefining some little parts, like you are either changing a variable or either changing the function or you are doing it. You can ask me question, right? Okay, I have now a design with all the things. Can I eliminate some of the designs, some of the features from the design? Yes, you can do that. some
Yes, we
some
can.
guy says in the design I have a, see, in the calculator I have add function, subtract function, multiply function. Like say, in a house, right? I have a bedroom, I have a hall, and then I have a kitchen. So in this object I'm only using add, I'm not using subtract or I'm not using multiply. So that doesn't mean that in the design it used to have, but I'm not using it. Means a user also will have a selection of what he needs. Means if he don't
Mm-hmm.
want two of them, he can just eliminate them. So whatever he wants, he can take it in the design and he can implement it. If he don't want, he can just don't call those functions. That's it. So don't call that variables. That's it. So he'll have a prototype with all the functionalities. But if some doesn't have anything, he doesn't want some of the features. He can just simply don't call that function or don't call that variable. So yeah, so that by default it'll get whatever it is. It's a
Yes.
plain, the design of whatever the systems that we make, and then from the prototype when we bake a concrete particle out of it, how it behaves. It's the same thing called object oriented program. It's like object, and then the prototype is called the class. So got it?
Yes, yes, Bharat. Thank you.
Yeah, I want to be very very clear on object oriented. See, object oriented programming is visualization. It's not like it's not it came up with whatever we are doing in each and every day. So it's not that in a general, if you go to C++, you can write 100 functions in one single file. So when it becomes complexity to maintain it or to reuse it or to find out where it is. So why object oriented programming has so much of importance is, so when I say mm, I have something called in a room I have two shelves. I have named it as shelf 1 and shelf 2. I know what is in shelf 1 and what is in shelf 2. I know what kind of books you have aligned in shelf 1, and I know what kind of books you have aligned in shelf 2. In another room I have one shelf. I don't know, all the books are mixed matched and everything is kept it. So is it easy to find a book in the first room or in the second room? So in one room I have 3 or 5 different shelves where I have actually kept, by segregation. Like if I want all the bio books, I put it in one shelf. If I want any other books, I put it in other shelf. I put it in all in one, segregated properly, with some convention and everything, and I put it into a room with separate racks, and then kept it everything clean. In another room, I have only one shelf. Everything is mixed max there. To find out something in the first room, it's easy, or second room, it's easy.
First one is fine.
Yeah,
First
why?
one.
Because you have already designed in such a way that you have made the sections of it. You told that each section has some proper this thing. You told that okay, it can have the capability of only keeping bio this thing there. So now if you want a bio book, you know that okay, shelf one has bio. So you will go directly to the shelf one and you will pick the book, and or if you even search there, right? You are not searching on all 5 shelves. You are only limiting your search to only one shelf, and then from there you will pick the book and then you will go. So if you take all of them in one shelf, you have to first of all find out where that book is, and then first of all you have to go through a lot of things and then find out where it is. So see, if you think of in that manner, right, the maintainability, the reusability, or the way the code is written, the structured pattern, all those things are very good in object oriented programming when you compare to the regular traditional programming like C++ or C. If you think of a C programming, it's one bookshelf with all the functions. If you think of a Java, it's more abstracted. Abstracted means it's more divided, properly guided with not different names, and then it has like inheritance and all those stuff. So it's a very good thing to write program in object oriented programming than the normal, C C plus plus. I mean, it's normal traditional programming approaches. Okay, so enough of that lecture. So I'll just go ahead into so what are different types of data types that we have in Java? Okay. Okay, this I have not, again, these I have not added there. I have to add these things also, but I'll just give me some time today. I'll add it. Okay. So I'll go to the Java presentation too. So these are different data types in Java. Byte is a number data type. So it can store from 0 to 127, number 127. If you know the algorithms, I mean, if you know the bytecodes of zeros and ones, right? So it can only store 2 power 8, I believe. So 2 power 0 to 2 power 8. So this is 0 to 127, and then it short is another number format. So which is little bit more memory than byte. It can store somewhere to 10,000s, and then integer is a bigger format than short, and long is another bigger format than integer. So long can store more bigger number compared to integer, but even long has some limit. You cannot store all the numbers. Okay, at some time it'll run out of the numbers, and so it has a memory allocated, and that memory uh, has limited section, so it can just run it can just store some set of some specific upper limit. So after that it will throw an error. Okay. So byte, short, integer, long is all numeric types. Means you can store numbers 1 to 20, 127, or 1 to like say 10,000, or 1 to 10 lakhs, or billion, or 10 billions, or whatever it is. Double is decimal value. So double a boolean, I mean, double or float or decimal, whatever you call different these things. It's a dot. 0.0 is a double. Character is a single character. So if you have C, A, B, C, D, so that's all characters. Boolean is true or false. So if you want to define something called true or something else called false, then you can define as Boolean. String is pretty much set of characters. So you have like a set of characters like this is a pen, then that's a string. Okay, you have set of characters there. So why string is not a basic data type is because it's made up of characters. So that's why they have put it as non-primitive type. So So string is set of characters, boolean is true false, and then double is whatever we have. um, the 0.0s are called doubles, and then all the other types are long. So why they have different types for numbers is because, to if you want to not use more memory, and if you want to use less memory, like you have to have age, right? If you just wanted to limit your age to 0 to 127 as the years, so then you can just use byte instead of going to long or integer, because it'll consume less memory compared to the by integer or long. So if you think that if you want to give speed 0 to 100, right? So if you want to give just speed 0 to 100 or 0 to 120, you don't need to use short, integer, long. You can just use byte. The same way short applies. Like if you want to give to 0 to 10,000 or something like that, then you can give short. The same thing if you want to just give more numbers, like YouTube videos which comes into millions, they can use integers, and then long for the bigger ones. So, but if you ask me, it's only for a memory constraint. If you are not comfortable in using others, you can just go, if you know of integer only, you can just use integer. But this is all for memory and for developers to save some memory. So they have different types of data types. So these are data types. When I say data types, so these are some types of data that you can store in Java memory. Okay. So now you can store int ABC. So int ABC means all ABC of type integer type. So you can store three numbers into like A can store one number, B can store one number, and C can store one number. So currently, when I say int A comma B comma C, a memory location, like say in the memory, it will allocate a memory. But it doesn't have any value now. It has nothing. So there is no value. It's null. So, but it has in the memory, in the runtime memory, it allocated some memory which is called A, and how much memory it has allocated based on the type it will allocate. So it is now 2 power 10 or whatever it is, 2 power 10, then it will go and give that much of memory based on the integer or byte or whatever it is. And then so for A you have some memory, and for B you have some memory, and for C you have some memory. Okay. So when I say A equal to 10, right? So in this here, 10 is getting stored into that memory. So you are giving 10. So 10 is getting stored into A. So means A is some memory that is now in the memory location. So sorry, when I say int, there is a memory location that is got created. The name of the memory location that created was A, and the value that is stored in that memory location is 10. So that's how A equal to 10, int A equal to 10 is. This is called initialization. This is called declaration. So when I am initializing a value, there is a value that we are storing into a data type called integer, and the name of the data that and the memory location that you have given is A. So A is the name of the memory location. When you say A, you will get 10. When you say B, you will get 10. The same thing goes here. When I say byte B equal to 22, is storing 22 now. So the type of the memory is byte. So when I say int and byte here, right, the memory that is consumed by int is more, and the memory that is consumed by byte is less. But the same 22 will take the less memory, but 10 it will take more memory. The same thing goes to double also. If you see here 3.1.4, whatever it is. So pi is the name of the memory location. The type of the data that is stored is double, and the value that is stored there is 3.1.14159. So pi, when I say pi, it will give you the 3.141. Okay. So when I say character A equal to A, means A is the name of the location, and then character is the type of the location. It can only store one value, which is character, and then A is that value that is stored here. Okay. Any questions? Yes. Any questions? No. Yes.
No, I'm good.
Okay. Yeah. There's only two answers. Yes. No. All right. So three answers basically. So okay. So then we go through the access modifiers. I go later, or I can go to. I'll go to operators, and then I'll go to access modifiers. Okay. So now that we have seen, right, here in the code, So if you see here, now we have number 1 and number 2. So int is the number 1 and int number 2 is what we have here, number 2. So but there is no value that is allocated here. I mean, there's no value 10 or 20. We have not indicated any value. So when are we giving to this memory location value? Whenever we created an object. So here we are assigning a value. For that C2, we have like the structure, right? Number 1, number 2 add. So we're giving a number 1 21 and number 2 as 32. And then when I say we have not written any logic, we can say sysout. So I'm writing the logic now, adding two numbers. So, and then after adding the two numbers, I'm just appending that to, and then I'm saying number 1 plus number 2. So when I say number 1 plus number 2, it will just add first the number. That's why I'm giving a bracket. It will add number 1 and number 2, and then it will give you the value. Okay. The same thing if you want to perform subtraction, we are going to write the logic. Okay. So now if you see plus, minus, star, here there is a plus. So there are a lot of operators, right? So if you just go to the main class and now run this class, right click and run. So run as Java application. So it is asking to save the classes. You saved the classes and now see. So you have given 21 and you have given 22 in the add. If you go to the control and click the add, it will go to the logic. Or here it's mine is Apple, so I just click on command. So command add, it will go to the logic. So it now implemented it took the numbers, number 1, number 2 when we created an object, and the logic that we have done is this one. So adding two numbers, number 1 and number 2. So that got executed, and then we got the results. Adding two numbers is equal to 53. So that's how it got executed. But when you clearly see, we have some operators that we are using here. So there are a lot of different operators that we can use while programming in Java. So what are those operators? Let's go and see the operators. Okay. So in Java, we have arithmetic operators like plus, minus, etc. Relational operators, we'll see what those are. Bitwise, we don't really care. So I don't really worry about this. Logical operators, assignment operators, and MISC operators. So we'll see what different operators we have here. Okay. So let's go to the operators. Arithmetic, plus is plus, minus is to subtract, star is for multiplication, this one slash is for division. Modulus will give you the reminder. Basically, if you know modulus, it will give the reminder. Like when I say 3 by 2, it's a 3 modulus 2 is reminder is 1, so you'll get the reminder. Plus means incrementation, it will increment by 1. Minus means decrement by 1. Okay. So plus, minus, star for multiplication, division, and then reminder, and then you go to the plus and minus. The second one that we have is compare relational operators. Equal to means the left hand side is equal to right hand side. The not equal to means whenever we are comparing, the left hand side is not equal to the right hand side. The left hand side greater than right hand side, left hand side lesser than right hand side. Left hand side greater than or equal to or lesser than or equal to. See, these are different operators and examples. The logical operators, anyone know what is and or operators? So anyone know what is and operator and an or operator in mathematics? Generally, I'm not speaking about computers. So what is logical and? True and true is? What is true and true?
True.
Logical operators, true and true is equal to?
It's true.
So when it will become false, an and operator?
And this for if any false is there, and then it will become as false. And or
Yeah, correct.
if any both of the false, then it is going to be false.
Correct. So whenever in OR operator, it's just a reverse. So I mean, false or false is still false. True or false is false, and false or true is true, and then true or true is true. Okay. Sorry, true or true is true. False or true is true, and then true or true is sorry. True or true is true. False or true is true. True or false is true, and then false or false equal to false. The not operator, the third one that we have, which is called not operator, so that is nothing but if you have a true statement, then it will become a false statement, and if you have anything called false statement, it will make it a true statement. But I don't really use this operator much, so don't worry about this thing. Okay. The assignment, so this is wrong. So bitwise operators are there, but just leave that. So you need logical operators, you need relational operators, you need arithmetic operators, and you need MISC operators. This is a separate way of writing if statement. When we do the if statement, we will check it, and this is checking whether your object is coming from that class or not. So for example, right, the instance of operator is used to just check whether the object that you have created is coming from the class that you think of. Like say, what is the example here is, so when you go to the thing, right, we have created something called C2 now. The C2 is coming from calculator class. How do whether I know that C2 has a type, C2 is of type calculator class? So when I say C2 is instance of calculator class, it will say true or false, because so that means the C2 is generated from a class called calculator class. So that's how it instance of class will help you. So what are we doing is we are checking whether the origin of this C2 variable, which is instance variable, is coming from the the class that we think of. The so origin is from the same class or not, that we'll verify it. So so that's one thing that we can do. Okay. So that is used by instance of operator. We'll see examples in the tomorrow's class. Okay. So So when I say here, right, when I say here public, and then we have private, we have default, and we have 4 access modifiers. So what are access modifiers and what they does, we'll discuss, and we'll close this class. Because there are a couple of there is a girl that who is joining the class, and then so I have to accommodate her. So I just need to cover up all these classes also for her, and then she'll join from tomorrow, I believe. That's what I'm thinking. So but let me confirm and let you know, guys. Okay. And then so let's go to the access modifiers. So what are access modifiers and what do we do? So we're discussing about access modifiers. Access means, you know that, right? So whether you're giving a privilege, right, to see or not, correct? Access modifiers. So you are now giving whether you can really you are giving that visibility or not, is giving an access, correct? So when I say public, right, when you define anything public, a variable public or a method public, correct? A variable is anything saying int a or int b or int c, public int a, public int b. So those things, int a, int b, so those are variables. Variables is anything that stores a value. So stores is, it's a memory location that stores something, correct? So variables like a comma b comma c, whatever we give, right? So if you give them, you can give access modifiers those variables at class level. Okay, so we'll discuss what is at class level and what is at a method level, etc. So but whenever you declare a variables a b c in a class level, so then you can define them as public, private, etc., etc. When I say public variable, means when I declare them as public variable, public a or public int a, so then this visibility is to everyone. Whoever can see this Java program can see a. So when I say private int a, then then it can be only seen within the class. You cannot see outside the class. Means when I create a class, right? So when I create an object out of the class, I cannot see A. Only within the class I can see A, but it doesn't belongs to any object, or because the visibility is not there, you are not allowing it to show to the other guys. So the visibility is not there. Okay. So, and if I don't define anything, like if I don't define print, public A or whatever it is, and I just define int A, so then that becomes default. Default means, so it can be only visible within the package. When I say package, we have seen right yesterday folder structure. So within that folder, the same folder we can see when it is default. And when we say protected, I'll come to the later. It is an inheritance rule. So when I say protected, you can see with to the all inherited classes. So this I'll cover when I'm covering the object-oriented programming. So because it is more related to OOPS concepts. So but when I say protected, it can be seen by only the inherited classes and within the package. So and public can be seen everywhere. So either a variable, it can be a function. So both we can see in the classes, right? Like functions is add method or etc etc, and the variables would be like in the calculator we have seen int1 or int2. So those things are variables. So for those things, when I define public, these things can be wherever I create an object or everywhere they are visible. Means when you want to see it, you can see it. When you declare it as private, you cannot see the variables that you have declared in the class. You cannot see it anywhere. So not visible at all. So when you declare, when you don't give anything before private or public, then it is called default. And then that default you can see only within the package, within the same folder. And then when I say protected, you can only see in the inherited classes and within the package. So these are different classifications of different axis modifiers. We have 4 axis modifiers which can tell what level of visibility we have. When I say public, everyone everywhere you can see them, you can view them, and you can access them. Private is it is not visible at all to anyone. It's only within the class, not visible at all, and within the class. Correct. So that is another important thing. It's within the class. When I say default, you can see within the package, like which is called the same folder. And when I say protected, you can see it is in the inherited classes. So we'll see when it is going through the inheritance thing, which is called protected. And you can also see within the package as we see in the default thing. But the extra thing from default to protected is you can also see it in inherited classes. So what is inherited classes, how we can see, we'll see it later. Okay. Now just let's take an example. Now if you see here, when we created an object, we see C2 equal to num1 equal to 21, C2 equal to num2 equal to 32. So because now I have given it, I have not given any axis modifier, it is taking default modifier. So if you have seen, I have not given public or I have not given private, etc etc. I've just given. So why it can see? Because it's in the same folder, it's in the default package, and they are both in the same folder. If they would have been in a different folder, then this thing, the main class, the visibility would have been gone. So now public you can see anywhere, so there is no differentiation. When I say private, let's move it to private. The variable I'm changing it to private, and then I'm just moving this variable to private. So 2 variables I moved to private. Immediately when I come here, right, you are getting an error. Means the visibility got changed. Change visibility of num1 to package. So so you are telling something in the class that they are local and they are not really exposed to outside. Means you are telling in the object they are only to locally do some calculation, but not to be visible to anyone. So when you are saying that, you cannot see outside those things at all. So that's where we are getting an errors, and Java is also suggesting us to change it, because you are accessing it here, but your definition of what you have given is correct, not correct. So that's why it is telling go change there. But if you want to, if you do like this, then you cannot really go ahead and access it when you say private. But when you say public, you can access it. When you say default, within the package you can access it, and within outside the package you cannot use it. Let's change it to public. So public means you can access it anywhere. And I'm changing one of the method to private. Means instead of changing the variable, the state, I'm changing the behavior now. So I'm changing the behavior to private now. So now if you go to the main class, you're not getting error there, you're getting error here, because the visibility of the method has been changed now to private, which is internal method now. And then the other two errors got cleared because the visibility got changed. Okay, so now here if you see, okay, now it's asking me to change the visibility. When I change the visibility, so it took the default visibility, means because within the same package I can access, right? So but if I give public, then it can be accessed everywhere. So these are access modifiers. As I said, access modifiers will define the visibility of your functions and variables. So if you can just say public, then it can be visible to everyone. Private, it's only visible to within the class, and then the default within the same package, and then the protected within the same package, and then the inherited classes. Inherited classes we have not seen it, but we'll see it later. So these are different access modifiers. Okay, public, private, and then the default, and then the protected. So any questions, guys? Thinking? Yes, no? Okay, just take this task, okay, and I want you to complete and send me the assignment. Create a calculator class and try to add two numbers, and try to add two strings, not numbers. Try to add two strings. Like say when I add Ram and Rajiv, then it should give me Ram Rajiv. So like that, add two numbers and two strings, and then send me that code. Okay, you have to create a class, you have to create an object, and then you have to add two numbers and add two strings, and send me that assignment. Okay, I'm just writing it down again for your reference. So you have to create a Java project. Under the Java project, you have to create a class. So basically, it takes it has four states. I mean four variables, two numbers, number one, number two, and two strings, str1 and str2. And then when you add numbers, when I add numbers, I have to add the numbers and get the output. And when I add the strings, I should get, when I say Ram and Rahim, if I add, I should say Ram Rahim. So like that. Okay. So just try to create two functions and four variables into a class, create an object, call it in the main method, and then just run the code and just send me the code. Okay. So and then I have to review the code. So basically just create one small Java project and just do all these things and get back to me. Okay, any questions?
No.
Okay, so can you do this?
Ambara,
Yeah.
Ambara,
Yeah.
Bharat, I have a question.
Uh-huh.
If you do recording,
Uh-huh.
if the screen is on, I don't think you have to highlight the screen also. The
I'm not
screen.
sure. It is recording the whole screen, right?